Welcome to Virtualize Everything. Today, we're going to be building a supercomputer inside of Proxmox. Well, before you start rapidly typing in the comment section below, we're going to simulate a computer, a supercomputer, inside of Proxmox using containers. So, I wanted to play around with MPI and learn a little bit more about how supercomputers share data and whatnot. Now, for a while now, people have been turning to Raspberry Pis and building clusters out of them. This is all fun, but if you don't have Raspberry Pis on hand and still want to learn, this can be very complex today in 2023. So, let me show you how to do it in Proxmox so you can learn about interacting in a supercomputer, how to write distributed or parallel computing applications, and generally explore. You might even find this is a little bit more convenient to learn with than Raspberry Pis. So in order to start out building our own supercomputer, or at least simulating our own supercomputer inside of Proxmox, we're going to need a collection. We're going to need a collection of containers. Our server here that we're going to be working on has 4 cores, and we're going to want to leave 1 core for most workloads available for Proxmox in order to keep things running fairly smoothly. So we're going to build a 3-node system, 1 master and 2 workers. So the first thing we're going to need to make that happen is 3 separate containers. I'm going to show you how to make the first container, and then I'm going to allow you to make the other 2 by yourself. So in order to make our first container, we're going to hit Create CT. And we're going to choose an identifier that kind of keeps things a little bit separate. Now this is entirely up to you what identifier you choose, but I'm going to just keep things separate by choosing 500. And let's give it a host name. Now host names are fairly required, and they do make working with these nodes a lot more efficient and easy. So the first host name we're going to call for our system is going to be master, and we're going to set up our password, leaving nested and unprivileged containers checked, and we're going to leave SSH keys alone as well for the time being. Under templates, I'm going to choose Ubuntu 22.04 as it's the latest long-term release of Ubuntu. We're going to use 8 gigs, 1 CPU core, 512 memory will be sufficient. And here under networking, I'm choosing a separate VLAN, which is tied to a bridge from my network. And I'm going to choose static. You want to make sure all these have fixed IP addresses. And I'm setting an IP range that's inside of my IP range for this particular VLAN, but out of the way of where I assign addresses with DHCP. And I'm also ending that in a /24 to denote my CIDR notation. /24 is a standard 0 to 254 network, and /32 is a singular system, just so you have reference. For my gateway, of course, I'm gonna point it at my router, and my router that assigns addresses and is my general access point for the internet in this IP range. And I'm gonna leave the rest of the configuration alone. For DHCP, or for DNS, we'll leave it the same as our server, and we're going to press next and finish. Now, to create my other 2 containers, I could walk through that entire process, or I could select my container, right-click on it, and clone it. And let's call this 501. And we're going to give it a new host name of worker1. And then I'm going to repeat the same process to create my last node. Now with our 3 new containers created, we can go ahead and start each one of them up and open the console on them. We log in with root and the password that we set up when we created the container. First thing I want to run is an apt update. And let's go ahead and make it easy and string it with the upgrade as well. So we're going to put 2 ampersands and we're going to write apt upgrade -y. Now I'm going to copy this command because I'm going to execute it for the other 2 containers. Alrighty, so now that we've done our updates and our upgrades on all of our containers and got all of our initial software installed, let's start out by creating a new user for each and every one of these containers. SSH doesn't traditionally allow you to use the root user account, so we want to try to avoid having that. So let's just use the add user command and add a user by the name of VE. And then let's also add that user to sudo group just to make it easier for anything else that we do later down the road. Now I'm going to go ahead and do that step on the other 2 containers, and I'll be back with you here in a moment. So with our new user created, let's go ahead and run the command su, and then our new username, which in our case is going to be VE, which is going to log us into our VE account, and then we're just going to cd to /home/VE so we can work there. And I'm going to once again do this on my 2 other containers. So now we're going to want to create some SSH keys, and we're going to do that with the command ssh-keygen --t --RSA. And once again, we're going to do that at all 3 nodes, pressing enter for all of the questions that it asks. What this is going to allow us to do is have SSH communication between each node without having a particular password and username that has to be exchanged, as MPI doesn't work very well with that. So the next thing we're going to have to do is actually copy our SSH key to our other systems. So our master has to be distributed to our 2 workers, and each of our workers have to be distributed to our master. So here we have the master, and to do that from the master, we're going to use the command ssh-copy-ID and then the IP address of our workers. So the first worker is going to be 192.168.5.201 in our case. So when we set up our particular workers, we forgot a step, and the step, when we cloned it, we actually cloned our IP address over for each of these workers. So we have to go in and select the worker, go into network, hit edit, and we need to change each of these IP addresses to be unique for each individual worker. So for worker 1, we're going to change it to 201. And for worker 2, we're going to change it to 202. And go ahead and start these workers back up. And now we can reattempt to send that SSH ID over to these workers by hitting the up arrow. And again, the command is ssh-copy-ID and the IP address. So yeah, this time we're asked to identify if this fingerprint is okay. We enter yes, and then we need to enter that system's password and it's copied. We're going to do the same to 202, which is the other worker. And it's copied. Now we want to go ahead and go to each one of these workers and execute the same command. But this time, we're going to send it to 200, which is the IP address of the master. And again on the final worker. All right, so everybody has their own unique SSH key now, and they're going to be able to communicate with each other without an SSH password. The next thing we're going to need to do is actually install Python 3 and MPI for Python onto each of these systems, and this is what we're going to use to create the cluster or the distributed computing system that's going to allow us to write Python programs to use the CPU power of all three of these nodes for the same task together, controlled by the master node. And since we're no longer here in the root user, we are going to start using sudo. We're going to use the command sudo apt install. We're going to install mpitch python 3-mpi for Python, or for Pi. And we're just going to add a -y to the end of this so that it executes with the yes question on without us having to give it that feedback. We'll give it our sudo password or our user password, and then we'll execute this on our two other nodes. So now let's test and see if MPI is working. With the command MPI exec -n designates how many nodes you want, and if you put 1, it's always the node that you're executing the command on. So we're going to run a -n1, and then we're going to ask it for the host name. And it comes back master. So now let's execute it on our two other workers and make sure that they're coming back as well as worker 1 and worker 2, and we're able to continue on now at this point. So from the master, we can again run the hostname command, but let's change it to 3 and tell it the IP address is of the other workers so that we can make sure they can communicate with each other. In order to do that, we're going to do a -H, and then we're going to give it the IP addresses of all 3 nodes, including the master node, that are separated by commas. So 192.168.5, 200, comma, 192.168.5, 201, comma, 192.168.5, 202. And then space hostname. And this comes back master, worker 2, and worker 1. So we know that our cluster has now been made, and everything's up and running and communicating with each other. So the next thing to do is to upload a Python script and test everything out. So one fun one that a lot of people use when they're building out this type of MPI cluster with Python is to calculate prime. I'm going to go ahead and grab a script from the internet for doing just that. That's designed to work with MPI. So now that I have the script, we're going to need to, of course, store it on each one of the servers so we can execute it. So in order to do that, we'll start here at the master, and we're going to enter nano, and then let's just call this prime.py. and we're going to copy this script in. If you want to use this script or at least see the credit to the creator of this script, go ahead and check the comments below. I'll provide a link to this particular creator so that his work can be recognized and you guys can use it. But here's the script. It's right here. It's going to calculate prime numbers and it's all set up for MPI. All right. So now we'll hit Control X to save it and Y, and this script is good to be executed on this particular node. But what if we wanted to execute this script on, say, worker 2 and worker 1 as well at the same time? Well, if we tried to do that right now, we would get an actual error message. So that, of course, isn't going to work very well for us. So let's take a minute and think about how we're going to get it over there. And the easiest way that I have is to use SCP. So let's enter with SSH keys all set up. That's a pretty easy process. So let's enter SCP space squiggly line slash the file name prime.py, the IP address of the node, and a colon. And you can see that we copied that file successfully to the first worker. We'll change this IP address to 202 and execute it again. So now, if we went over to worker 2 and we ran an ls, you can see that the prime file's there, and the same for worker 1. Now, of course, it will be, we have this file on all these workers, and it's going to be great. Let's fire this off and get it running on all nodes. But how do we really know if all of these nodes are being utilized or if there's any time savings or anything else? Well, the best way to tell is going to be time. We can, with Proxmox, can look at our statistics and see our CPU usages, but time's the big advantage, right? This is what we're doing multiple cluster computing for, is for time savings. So let's first look at running this script on one particular server, see how long it takes, and then look at what it takes to run this script on more than one server. So here on the master, we're going to run that MPI exec command again. And we're going to put that -n, designate that we're using one node or our master node. Then we're going to tell it that we're running Python 3, and we're going to run the prime.py script to 1000. So the prime number that we want to calculate all prime numbers up to 1000. Now 1000 I find is about a 1 second workload on one of my cores, and it's really going to be hard for us to determine if there's any particular time saving. So let's go ahead and add a 0 to this workload. So we're going to do it to 10,000 and see how long that takes. Now that came back at 0.53 seconds, so that's not a very heavy workload, and it doesn't take very long. I still don't know if we'll see a great time improvement with the two other nodes, so let's again add one more 0 and execute it. Now all that's running, if we open Proxmox here, it just finished. So let's bring up our Proxmox window and execute it again. So if we full screen our Proxmox window and we go to summary, you can see the master here has a CPU that's fully pegged out. Now, if we come down here to worker 1, you can see that the CPU isn't. And if we looked at worker 2, and if we look here at worker 2, it's also not pegged out. So we know that only the master right now is actually having a workload. So let's look at making this run on all of our servers, on our 2 other nodes, our worker nodes. And to do that, of course, we're going to change that -n to -3. Then we're going to put a space, and we're going to do a $uppercase and we're going to fill in those IP addresses, just like we did for the hostnames command to run on every particular worker. Now, before I press enter and execute this, I do want to turn your attention to the last execution, which the time elapsed was 41.03 seconds. Now, I'm going to keep that up here on the screen so you can see the time change between using 1 worker and 3 workers. So let's go ahead, execute this same command to 100,000 and see how long it takes with 3 workers. So with it running, we can come back and we see worker 2 is at 100%. And there's our time difference with 3 workers. We go from 41.03 seconds to find 9,592 primes to 33.73 seconds to find 9,592 primes. So we found the same number of primes, which definitely should have happened, but we did it in less time. Now, if this workload extended out from 100,000 to 1,000,000 and so forth, we're definitely going to see greater and greater time savings between adding nodes and the number of available nodes. So I hope you found this presentation fun and useful, and you'll be able to begin working on your own supercomputer projects, or at least experiencing and playing with MPI before you're able to actually commit the investment of getting multiple Raspberry Pis or like a Turing Pi or something like that. You're able to learn all about it and find out if this type of work is for you, and definitely experience it using Proxmox. So I hope you enjoyed tonight's presentation. Please like, share, and subscribe to continue to help virtualize everything grow. As always, have a good night.